Started from quantum mechanics. It's the year 1900 to the present. That's modern physics, quantum mechanics. Quantum mechanics studies particles, subatomic particles. At the beginning, people used to think that everything is made up of small particles called atoms that can be broken down. Atom is a Greek word, it means cannot be broken down. And around the year 1800s, John Dalton came up with concept of atoms like this, like solid spheres, small balls, very strong, that cannot be broken down. Then came 100 years later, at the end of the 1800s, the Plum pudding model. It was J.J. Thomson. He said it's something like that, and on it there are electrons like this, like this, like this, like a plum pudding. Electrons are negatively charged and this whole shape is positively charged. That's the concept came. But the actual model of the atom that we know today came in the year 1913. It's like we have protons, then we have neutrons in the middle. Protons and neutrons make up the nucleus, and surrounding them we have electrons that move around it. So that's the modern version given by Rutherford. How did he come up with it? He was a brilliant teacher and many of his students won the Nobel Prize. Two such students are Geiger and Marsden. They were in the basement of their university, and the experiment was like this. There is some sort of a source of alpha particles. So this is the alpha source. It emits some alpha particles, and then there is a gold foil, very famous experiment, and surrounding the gold foil, to know where the alpha particle hits, there is a screen. This screen is a zinc sulfide screen. It has a quality called scintillation. Whenever the alpha particle hits it, it will glow. So Geiger and Marsden, they had to count it, how many hits the wall and how many passes straight through. So this is how the experiment conducts. Rutherford knew that about the Plum pudding model. Accordingly, he thought the alpha particle should go straight into the gold foil and hit the wall. But what happened was so shocking. He said, as if a bullet was bounced off a tissue paper. It was so shocking. This is what happened. Alpha particles came through, most of them passed straight, but some of them deflected slightly like this. Some of them deflected more, but there were some that completely bounced back. Now this is extremely shocking. How is that possible, that some completely bounced back but many passed straight through? So from that he came to the conclusion that atoms are mostly empty space. So mostly empty space, because most of them pass straight through. Then he came to the conclusion that since some bounced off directly back, so it has most of its mass at the center. So from that came the Rutherford's model of atom. This is the atomic structure. Now talking about the atom that has in the middle at the center, that's called the nucleus. So this is the nucleus. This is the nucleus of the atom, made up of protons, which are positively charged, and neutrons, which has zero charge, and surrounding them we have electrons that are negatively charged. Now one thing is important. The atom is so much empty space that if the full stop on a page was the nucleus, then the electron would be 2.5 meters away. That's how big and empty the atom is. Now electron's mass is extremely low. If the mass of the electron is 1, then protons are 2000 times heavier. So that's how light the electron is. Protons and neutrons are 2000 times heavier, and the protons are joined together by a force. That force is called nuclear force. Nuclear force. So this is a special force. We have gravitational force, we have electric force. This is a nuclear force. The protons are joined together in the nucleus with nuclear force. Now protons and neutrons and electrons, these are called particles. Protons and neutrons, they are also called nucleons. So protons and neutrons, since they belong to the nucleus, so these particles are also called nucleons. And it is important to remember that when we talk about atom, it is expressed in certain way. So if we express the atom in this way, suppose this is the name of an atom, name of an element. Now here, the letter that we write here, that letter is known as the atomic mass. The atomic mass is made up of neutron and protons together. The total number of neutrons and protons is called atomic mass. Below that, here, this is called atomic number. Atomic number. Atomic number is just the number of protons. Now in an atom, the number of proton, which is positively charged, and the number of electrons, negatively charged, are equal, so that atoms are neutrally charged. So atoms are neutral. Atoms are neutral because the positively charged and the negatively charged, they cancel each other off. So whenever we are talking about the atomic mass or the proton number, that proton number is also the number of electron, because atoms are neutral. Now there is some other name for atomic mass. Atomic mass is the total number of neutrons and protons. So atomic mass is also known as nucleon number. Same thing. Atomic mass and nucleon number is the same thing. And it is also called mass number. Mass number, same thing. So atomic mass, nuclear number, mass number, they're the same thing. They're the total number of protons and neutrons. So that's how it works. So whenever we are talking about atoms, we are talking about the nucleus, which is made up of the nucleons, the protons, positively charged, neutrons, no charge, and surrounding them is the electron, negatively charged. Now the quantity of charge or the amount of charge is the same. Electrons are negatively charged, protons are positively charged, that's it. But charge, the quantity of charge that they have is the same, one positive, one negative. If the mass of the electron is 1, then the mass of the proton is 2000 times more, approximately 2000 times more. That's the mass of the protons. Now one thing needs to be clear about this, that whenever we are talking about atoms, various elements, they're actually made up of the same atoms, but the different number of protons, and particularly different number of protons and electrons, make them different element. Hydrogen, oxygen, helium, but the number of things that they're made up of, that's what differs. But it is actually made up of atoms. So electron is always electron, proton is always proton, neutron is always neutron. So there is not a different proton for mercury and different proton for gold. No, it's the same, just the number of protons and neutrons makes all the difference. So it is important to remember that. So when atoms have the same number of protons but different numbers of neutrons, so we call that isotopes. So whenever you see that the same number of protons, so if you, for example, if you see something X, suppose this is A, and we have another thing, this is Y, this is also A, they have the same number of protons, but the mass number, suppose this is B and this is C, that means they're isotopes. The number of proton is same, but the mass number, the nucleon number is different. So the nucleon number is different because definitely the neutrons are different. So whenever you see that the number of neutrons are different but the number of protons are same, they are called isotopes. Mechanics deals with the atomic particles, subatomic particles. So in an atom we have the nucleons, which is inside the nucleus. So the nucleons are the protons and the neutrons, and around them we have the electrons, and we express them in mathematical terms. Here we write the mass number, which is the total number of proton and neutron, and we write the atomic number, the total number of proton. Since the atom is electrically charged, the charge is neutral because the number of protons is equal to the number of neutrons, number of electrons. They cancel each other off, so it's a neutral element. So we have this.